Hey, this is about class 7, and there were three topics discussed in class 7. One was average speed, the other was density, and the third was mass and weight. Mass and weight and density have more to do with like in the class and activity packet. It had more to do with unit conversions and how to get from one unit to another unit, and using the formulas related to density and mass and weight. So I have done a separate video where I have gone through some example problems on this unit. Exactly in the first 9 problems of the document that I have uploaded on Canvas. So if you're interested in learning more about density and mass and weight, maybe you should check that out. But this will be all about speed. So the formula for speed is, I'm out of water. Anyway, the formula for speed is total distance traveled over total time taken, right? So in physics, you start with something like a formula, and you can basically derive units out of it. So if speed is total distance traveled over total time, then speed will have units like meters over second, because distance is on the top, time is at the bottom, or kilometers per hour, or more familiar one like miles per hour. Okay, so those are some of the units of speed. um, you can also see speed, you can get information about speed from a graph. Okay, from a graph with x-axis as time axis, and let's say the y-axis as the distance axis. And the choice of me making a graph to show you different types of speed, uh, 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 and the graph having axes, time and distance, the choice will be more clear as we go on. So let me divide this graph that you see in regions. Okay, so let's say this is 1 hour mark because we are on the time axis. This is 2 hour mark. This is 3 hour mark, and this is 4 hour mark. Okay, so they're almost. I've tried to make them equidistant, but if they don't look that they are equidistant, then please imagine that they are equidistant. And this is the best I can do. So 1 hour, 2 hour, 3 hour, and 4 hour mark, right? So let's call this point 1 here on the graph, 2 here on the graph, 3, and then number 4 right here on the graph. I want to show you 3 different behaviors of speed, and 3 different kinds of speed, if you want to say, it like that, from this graph. So let me first make that first region, region 1, 2, and make it big so that I can actually talk about the things that I need to talk about in that. So in the x-axis you've got time, and in the y-axis you've got distance. And that region 1, 2 kind of looks like that, right? 1, 2. Okay. So we know that this is 1 hour mark. It's also, do not get confused by that. Like if this is 1 hour, it starts at 0, and why is this like, why is this why is this length is smaller than this length if it starts from 0? The answer, it does not start from 0. I've just made a starting point, this point to be 1 hour. Actually, let me go ahead and just for the sake of not having any confusion at all, let me just mark this point to be 0 hour. Let's say this is the first hour, second hour, and third hour. Okay, let's just say that. Okay, so that's the point of 0 hour. So we're looking at 0 here, and then 1 hour here. Okay, let me break this further down into chunks of 15 minutes. So you got 15, 30, 45, and 60. So this is 15 minutes, 30 minutes, 45 minutes, and that's 1 hour. So you can see that in the first 15 minutes, means this much amount of time, the distance traveled is about this much. Okay, so the way I know that is, for 0 hour, I just go up and then go left, That's the point in distance. Okay. For 15 minutes, I go up and I go left. So that's the point. So in the first 15 minutes, that's the distance traveled. Similarly, if you do for 30 minutes, you'll find that it will be about like this will come here, go left. This is the distance for the next 15 minutes. For the next 15 minutes, it is this much. Okay. So as you can see here, one thing is clear that with every 15 minutes, it's traveling more and more distance, right? So for the first 15 minutes, it traveled that much. For the next 15 minutes, it traveled that much. For the next 15 minutes, it traveled slightly more. And for the last 15 minutes, it traveled this much. So this is a case where the speed is increasing. Okay. So this is a case when the speed is increasing. So let me just write that down here. Increasing speed. Okay. Now let's look down. Let's look at the region number 2, 3. So if I make the big graph for only region number 2, 3, so this is distance, and that's time, and this is for region number 2, 3. So 2, 3 is hour from 1 hour to 2 hour. Okay, so that's 1 hour, and that is 2 hour. Okay. Let's say this is 1.5 hour, and then let's say this is 1.75, and then let's say this is 1.25. Okay, so again I have divided that 1 hour from 1 hour to 2 hour into four like sub regions of 15 minutes each. I just want to see in each of those 15 minutes how much distance is being traveled, right? So for the first hour, if I do the same, and this time I'm not gonna do it as in a very detailed way as I did for this one, because you guys probably know by now what to do. So what you do is you go up and then you go left. So that's the distance at this for this time. You go up, you go left. That's the distance. You go up, you go left. So that's the distance for that time. So as you can see, for the first 15 minutes, this is the distance. For the second 15 minute, that's the distance. And if you see the third 15 minute, that will be the distance. And the fourth 15 minute, that will be the distance. So for every 15 minute, the distance is traveled, the distance traveled is the same, right? So this is a case when the velocity is constant, okay? So this is a case of constant velocity, constant speed. I'm sorry, not velocity, speed, constant speed, okay? For region 3 and 4, I don't have to make a separate diagram. I can just show you here. And for the second hour mark, this is the distance, and for the third hour, the distance is the same. So distance is not really changing from hour 2 to hour 3, which is the region 3, 4, right? So this is a case of zero speed, because speed is distance over time, right? So if the distance is zero, then the speed is zero as well. So this is a case of zero speed. So you can clearly see from this graph, if you have a graph like that makes a curve going up like that, then that is the region of increasing speed. If it is not a curve like that, but if it is a straight line like this, then it is a case of constant speed. And if it is a flat line like that, then it is a case of zero speed.